Okay, grade 10. So this is the grade 10 electrical circuits, and we have to start with the theory because the theory informs the mathematics. Okay, and so the theory is that when we have a series circuit, the voltage is divided and the current remains the same at every point in the circuit. When we have a parallel circuit, the voltage remains the same, but the current is divided. So a parallel circuit is a current divider, and the series circuit is a voltage divider. And what we mean by that is that when you have your resistors in parallel, okay, the voltage V1 and the voltage V2 will be the same, right? However, the current that goes through this resistor and the current that goes through that resistor is not the same, because the current has those two paths to choose from. Okay, in series, on the other hand, the circuit is dividing the voltage but not the current. So obviously the current is the same because look, it's traveling across the same branch, it's traveling across the same wire, but the voltage is split. Okay, the voltage is split in series, but the current is not divided, and the voltage is the same in parallel and the current is divided. So you need to make those you need to know that before you are able to start with any questions relating to circuit. Okay, here's the first example. As you can see, we have our circuit, we have a 6-volt cell. So I would go ahead and say that this is my total voltage, because that is given. They also give you the total current, so this is the I total, right? That is how much current is available to the circuit, to the external circuit. And then we explore it further and see that we have this resistor on its own. So we have that resistor, and then we go further and we see that the current will split over here across the two branches in parallel. Okay, so let's just change colors. Current will split across the blue and the pink branch, and of course these two resistors are in parallel, just like parallel lines in mathematics. Okay, and so we have the orange portion that gets a certain amount of current, we have the blue portion that gets a certain amount of current, and we have the pink portion that gets a certain amount of current. Okay, if we look a little further, we see that R1 is 2 ohms, and attached to it is a voltmeter, V1. Then we have another resistor with V2 and A2, the ammeter, and then we have the 2 ohm resistor with A3. Okay, so now we need to go ahead and answer the questions that they are asking us. Alright, so the first question is to calculate the reading on A1, A2, A3, V1 and V2. And then the second question is to show the methods of calculating the resistance of the circuit. So A2 is the purple one. They want to know how much current is going through the blue branch. So as you can see here, we have 2 amperes of current in total, right? And then it's shared between 2 resistors of the same magnitude. And so each of them will get 1 ampere because the current will split equally, because the resistance of the resistors are the same. And so the reading on A2 is going to be 1 ammeter. I'm going to zoom out. The reading on A2 is 1 ammeter because the current is shared equally. Then they ask us for the reading on A3, which I think is just as straightforward, because if 1 ampere is going this way, then the other one is going that way. So 1 ampere on A2 and 1 ampere reading on A3. Then the next one is to calculate the reading on V1. So we need to go back here, and I want you to remember that we can do Ohm's law for each of these components. Okay, so the voltmeter 1 is the current going through this resistor multiplied by the magnitude of this resistor. We can do it for this guy. V2 is equal to I2 times R2. V3 is equal to I3 times R3. And we can also do Ohm's law for the entire circuit, where we can say that V total is I total multiplied by R total. But for now, we focus on the orange portion, right? And if V is equal to I times R, we know that this resistor will get this 2 amperes worth of current, because all the current passes through that. So the current is 2 amperes, the resistor is 2 ohms, and so the voltage is equal to 2 times 2, which is 4 volts. And so of the 6 volts available, of the 6 volts that we have in the circuit, 4 volts are over here. Okay, 4 volts are over there. And then the next question is the reading on V2. Now again, we can do Ohm's law by saying that V2 is the current through here multiplied by the resistor. The current through this branch we've established to be 1 ampere. The size of this resistor is 2 ohms, and so we can say that V is equal to I times R, and so therefore V2 is 1 ampere multiplied by 2 ohms, which is 2 volts. Okay, then the final question is to show 2 methods of calculating the resistance of the circuit. So there are 2 ways to do it, and we are going to do both ways. Okay, and so we need to go ahead and find our total. We can either calculate the parallel combination and then add it to the series combination. So let's start with that step. Let's go ahead and say that R total is equal to the parallel resistance plus the series resistance. Okay, the parallel resistance is over here, and we get it from saying R1 times R2 over R1 plus R2, and the series resistor we know is 2 ohms, and so we just substitute 2 times 2 over 2 plus 2 plus the 2 ohms, which gives us 3 ohms for the total resistance. So that is the one way, 3 ohms, by using the individual resistors and calculating the totals. So that is option A. Option B, because we want R total, right, we need to use I total and V total, and we have both these values. I total is 2 amperes and V total is 6 volts, and so therefore if we go V is equal to I times R, that would mean that R is equal to V over I, which is 6 over 2, and that is how we get the 3 ohms for the entire circuit. Alright, and that is example 1 done. Please comment if you have any questions, and I will respond as soon as possible. Thank you very much.